We are live. So in this lecture, or in this video, I'm going to give an introduction to plotting in Python using Matplotlib. So we're actually going to use two libraries. So we're going to import NumPy as NP, and we're going to import matplotlib.pyplot as PLT. And so again, since we're going to do a lot of plotting, this is going to be common libraries that we're going to use in basically every notebook. So if you're going to have a function, we're going to need to define the x values and the y values. So the easiest way to do this is, so let's do x is np linspace. Let's do 0 to 10. And we're going to do 1,000 points. And then we can say y, if we want to, let's do, say, sine of x. And then we're going to do, so here we're just going to plot the sine of x. So we're going to do plt plot x, which is the x domain, and then our y, which is the y domain. And then we're going to add the comment plt show to make the plot show. This is actually not necessary in Jupyter Notebooks. I'll show you what happens if you take it out. So if I run this, what happens is now I get the sinusoid. So I have a sine from 0 to 10. If I take this out, it's just going to add some text there. It's going to say kind of this inline thing. So it's kind of nicer if I just do the plt show. You need the plt show if you're not going to do it in a notebook. That'll actually have a new window pop up. If you're doing this from a script and just running it from the command line, you'll have a window pop up with the plot. So we can do different kinds of things with this. You know, I can do like np times 2 times x. Right, I can do more complicated functions. So now we have twice the wavelength. I could do np sine times np cosine of x. Right, if I want to do more complicated function, right? Again, this is element by element. So what it's going to do is take the first element of this x array and calculate sine of 2 times that element times the cosine of that element. And so you can do all kinds of different functions here. So let's just use this function as a baseline. So the first thing I like to do with a function is I like to change the color. So I don't like the default values. So I could do red. And now I have a red curve. Another choice is blue. And I have a blue. It's different than the default blue. There's green, which is G. There's also K, which is black. These are the only ones I know off the top of my head. But if you kind of Google matplotlib colors, you'll find, you know, a whole swath of possible colors. So we have lots of different choices for our colors. But let's just do the red value as my default value. So the next thing I like to do is I like to change the line width. So I'm going to do LW. And typically I like to use the value 3. And I come back to this and you notice how it thickens up the line. So it's a little bit easier to see. You know, I could also be extreme. I could say the line width is equal to 10. And now I'm going to have a really fat line coming through this. But let's come back to 3. So that's the value. One other thing we might want to do is we might want to add a label. So we could do plt x label. And we can type the value x. We can do plt y label. And we can do the value y. And then we're going to see the x and the y being here. It doesn't have to be a single character. I could do the x value. I could also come down here and do the y value. And you're going to see kind of the axis labels here. There's all kinds of different ways to change things. In the sample code, I've done a little bit more complicated things. But here, maybe I want to do the font size. I want to make it a little bit big. I'm going to do the font size, and let's just set that equal to 16. And I'll do the font size over here equal to 16, and that kind of blows up the x value and the y value. We can also change the fonts of the tick labels on this. I'm not going to actually do that in this lecture, but a couple other things we might want to do is we might want to put a title like my plot. And again, I might want to set the font size, in this case, equal to, I don't know, let's do 18, make it a little bit bigger. And so I have my plot, I have the x value, and the y value there. Last kind of option you might want to add is maybe you want to do a grid. And now we have a grid, you know, makes it easier to see. You know, if we want to extract a number that x at, you know, this function at the value 3 is equal to 0, or roughly 3. So lots of different ways, lots of different options for plots uh, coming through that you can change. This is all kind of syntax specific to the Matplotlib library, so there's nothing specific about programming per se here. It's just kind of using how they set up the library that you can change all the different features. In all honesty, I often have to use Google and go to Stack Exchange or other sites to figure out how to exactly get a plot how I want it, or look at examples posted online and then kind of manipulate those examples to get a nice looking plot. One last thing is, functions are just basically defined as a locus of points. And, the more points we add, the smoother the function will be. So if I come down and only use 10 points, you can actually see a jagged plot. So here would be the first point, the second point, the third point, the fourth point, the fifth point, right? That doesn't capture the function because we're only sampling it at 10 points. If we sample it at 100 points, it starts getting smoother, and then, we can go to 1,000 points. It runs, it's even clearer. We can push it 10,000 points. This might, it didn't take a second. At least to my eye, there's no difference between 1,000 points and 10,000 points. Typically, I do 100 or 500 or 1,000. I just kind of play around with it to get a sense of this. So that's kind of some examples for plots. Let me come down to a new example down here. So let's do again XP NP linspace 0 to 10, and we'll do 1,000 points. So maybe I want to plot y is equal to NP sine of x, and then I want to say z is NP cosine of x. So I want to actually plot two curves on the same plot. And so this is relatively easy, so I can do PLT plot x comma y. Now let's do line width 3, and then color is equal to red for sine. And then for cosine, I'm going to do PLT plot x comma z, line width is equal to 3, and then color is equal to blue. And then I'm going to just do PLT plot. And what you're going to see is the two plots. So the red plot is our sine, and then the blue plot is the cosine. So one of the things when you plot is that the first time you call plot, it's going to plot the blue curve, and then the second time first time it's going to plot the red curve. Sorry about that, because that's the first one. And then the second time it's going to plot the blue curve. So the blue is going to be on top of the red. It's probably hard to see in this video, but if I did maybe 6 and 6, you can see clearly that the blue is on top of the red. The way to swap that around is I just take this over and I put that there, and then you'll see the red on top of the blue. Again, there's lots of different options in Python. We can make these curves transparent or change the level of transparency. So there's all things you can play around with, and you'll see examples later of that in class. All right, let's go back to our original plot. So one of the things we might want to do is add a legend to the plot. Since we have two curves, it's not clear which curve is what. So I can come over here and put label, and maybe I'll put this is my sine. And then I can come over here and put label, and this is cosine. And then I can do PLT legend, and maybe I want, let's just do legend. And now we start seeing a legend for it. So the blue curve has a sine, the red curve has a cosine. It's a little bit too small to see. So maybe I'll do font size of 16. And now it's going to be a little bit bigger. One of the things you might find is that often it's going to put this legend wherever it thinks it's best, but you might want to change the location. So maybe I'll do like location is equal to upper right. Maybe I want that. And it's going to move that legend to the upper right. If I just did right, it's going to come down and put it over here. I could also do lower right. It's going to be down here. And then, maybe I could also do upper left, right? And it's going to plot up there. So you can actually control where the legend is. It can get pretty fancy, so you can actually move the legend outside the plot. It takes a little bit more work, but in general, I just try to find a location where there's not a lot of curve space. So I'd probably do here, maybe upper. Whoop. Which one do I want to do? Upper center. So it actually tells you. This is actually one of the cases where your error gives you a clear kind of explanation. So you want to do, what is it? Upper center. All right. Is it center? Do I see upper center? Yes. So I can do upper center. And now it's kind of in the middle. So that's kind of another example with a plot. All right, let's play around some more. So everything we've done is lines so far, but we can also do points. So I could say x is equal to np linspace of 0 to 10. And maybe we're going to do 20 points here. And then I'm going to do a single plot here. So we'll do np cosine of x, and then we'll do plt plot x comma y, line width equal 3, color equal to red, and then we'll do plt show. And so this would automatically give us kind of a line plot where basically each point is connecting a straight point. But if I only want to show the points, I could put a big 0 there. And now I'm just going to have the points for the function. I could also do squares and I think diamonds. There's a bunch of different options. I don't remember all the top of the head, but I typically just use zeros, which are kind of the filled circles. I can change the size of those. I could do, marker size equal to 20. And then I'm going to have really big dots. If I come down to 10, they'll be a little bit smaller. If I want to connect those points, I can put a dash here. And now I'm going to have the dash connecting those different points. That's kind of a common one to do. One other thing you might want to do is dash lines. So let me just grab this code here. I'm going to actually grab all this code. So, I want to have a smooth one, so I'll do 200 points. Let me delete all this out. So if I want dash lines, I'm going to do just dash dash, right? And that's going to be dash lines. I think dash point is like straight line with like another kind of dash line curve. So these are things to play around with. I typically use dash dash for dash lines. And so that's kind of another option you can play around when you plot different functions. So with that, I think I am going to stop. Once again, if you have questions, post them to the comment section, post them on Piazza, and I'll do my best to answer them. Just a final comment, there's lots you can do with plotting, and I suggest you go to the different libraries, look at different, Google, matplotlib. You'll find lots of different examples. I posted a lot more complicated examples on Compass that I'm not going to cover in the lecture, just to give you a flavor of some of the things you can do in plotting. And then later in the course, we'll talk about plotting like 3D shapes or at least 3D surfaces, when we want to have like an X, Y, Z type relationship. All right, thank you.